Hi students, in this lecture I will explain how to draw the tree diagram of a given convolutional encoder. The question is, below figure depicts rate of constraint length 2 convolutional encoder. Sketch the tree diagram and also find encoder output for the given input stream 11101. So this is the given convolutional encoder. It has constraint length of 2, so the state of the convolutional encoder is represented by M1, M2. So in order to draw the tree diagram, we need to obtain the state table for this encoder. I am explaining the procedure to get the state table. So constraint length is 2 given. MSG holds the current message bit and M1, M2 represent the state of the encoder. So for the state, 2 bits are reserved for the state, so we can have 4 possible states: 0, 0, 0, 1, 1, 0 and 1, 1. If suppose constraint length is 4, we can have 16 possible states. So for the given convolutional encoder, we have 4 states: 0, 0, 0, 1, 1, 0, 1, 1. Let us represent these states with some symbol A, B, C, D. And we try to find the state table, because state table is used to draw state diagram, tree diagram and also trellis diagram. See, initial state. Initially we assume the encoder is at all 0 state, initial state. We assume all the this will be at 0, this will be 0 and this is also 0 and this will be 0. So this will be 4 states. First we try to take all the combinations. It is a binary convolutional encoder, so the incoming bits may be 0, may be 1. Only 2 digits are possible in binary encoding. Let us assume the initial state is, the encoder is at 0, 0 state. So we repeat 0, 0, 0, 0, because initial state, if the incoming bit is 0, and also we consider the case if the incoming bit may be 1. Similarly, for 0, 1, 0, 1, 0, 1, we repeat 2 times because the incoming bit may be 0 or incoming bit may be 1. Similarly, for state C, 1, 0, we consider for incoming bit to 0, we also consider same initial state for the incoming bit 1. Similarly, for 1, 1 state, we assume for incoming 0, incoming 1. So current state of the encoder, 0, 0 represents A and this is also A, B, B, because we assume to represent the states of the encoder with some symbols A, B, C, D. Now find the output of the encoder. It is the given encoder and it has 2 outputs. Output 1 we represent x1, output 2 we represent x2, and the final output is represented by x1, x2, x1, x2, x1, x2, so on, because this switch moves between output 1 and output 2 to produce the final output. So from this diagram we can represent the first output to x1 as the modulo addition of MSG plus M1 plus M2, because all the 3 states are connected to mod 2 adder, and the second output is connected to first stage and last stage, so MSG plus M2. So from these equations we can find the output of the encoder. So MSG plus M1 plus M2, this is MSG and this is the M1 M2. 0 plus 0 plus 0, this is 0 plus 0 plus 0, this will be 0, and also MSG plus second output will be 0 plus 0 will be 0. So that is why, so this is the x1 0 and this is x2 0. Rules for mod 2 addition will be like this. Modulo 2 addition is nothing but a exclusive or logic operation. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 becomes 1, 1 plus 1 becomes 0. Because in XOR, for odd number of inputs, the output will be 1. For even number of inputs, the output will be 0. That is why XOR function is also known as odd function. If the number of inputs are odd, output will be 1. Or you can also calculate from this, A exclusive B will be A bar B plus AB bar. So in this modulo 2 addition, 1 plus 1 becomes 0. Now let us calculate next state of given convolutional encoder. We know the initial state. Suppose in step 1 we take 0 0, all 0 initial state. After we apply the clock pulse, because state changes after applying the clock pulse. So this will go, we will discard this and this will come here and this will come here. So it will become 0 0. In the next state 1 0 0, again after applying the clock pulse, this 0 will be discarded, this 1 moves to next right shift by 1 bit, so the contents become 1 0. This will be represented by state C. Similarly for 0 0 1, after applying the clock pulse, this will be discarded after right shift by 1 bit. This will move to this place and this will move to this place. So this will be M1 M2. So the state 2 changes from 0 1 to 0 0. So 0 0 is the state A. Similarly we can find the from initial state to next state after we apply the clock pulse. Suppose initially if it is at 0 1 1, 0 1 1, after applying the clock pulse, this 1 will be discarded, this 1 will come here and this 0 will come here. So if the incoming bit is 0 here, the state 2 changes from 1 1 to 0 1. 0 1 is the state B. Similarly we can find the state of the, from this state to encoder changes from given state to the initial state to next state. So this is the initial state of the encoder for all possible combinations of the input and states of the encoder. So this will be the next state, AC AC BD BD. You can see we got to this thing. Blindly you can remember the next state of the encoder will be the combination of first two columns. This is 0 0, this is 0 0, 1 0, this will be 1 0. Similarly 0 1, 0 1 and the final will be 1 1. This way we will find the state table from the given convolutional encoder diagram. State table is useful to draw state diagram, trellis diagram and tree diagrams. From these diagrams we can find the output of the convolutional encoder for any given input. So please remember this. So state table is very much useful to draw the state diagram, to draw the trellis diagram, to draw the tree diagram and to find the output of the convolutional encoder. We have obtained state table, so now we are ready to draw the tree diagram or a co-tree diagram. See, this is the root node. This is the root node and the branches go up and down. If the incoming bit is 0, the tree grows upwards. If the incoming bit is 1, tree grows downwards. So from the starting point we can draw the branches of the tree in this fashion. We can extend the branches of the tree in this fashion. If upward, if the incoming bit is 0, we go up. If the incoming bit is 0, we go up. If the incoming bit is 0, we go up. So this is the convention we use to draw the tree diagram. If the incoming bit is 1, we go down. If the incoming bit is 1, we go down, like this. And see, this represents nodes. This represents nodes or a state of the convolutional encoder. So this is the root node and we have different nodes or states of the convolutional encoder. Each node represents state of the encoder. State of the encoder changes depending on the incoming bit. If the incoming bit is 1 or if the incoming bit is 0, depending on that the state of the convolutional encoder changes. So we need to find the state of the convolutional encoder and output. These are the branches. These are the branches. These are the branches. So output also we need to find from this diagram and the states of the convolutional encoder. Suppose from this state table, if the incoming bit is 0, so we start from the all 0 initial state. So this will be, we are in the state A, state A, initial state 0, 0. If the incoming bit is 0, suppose, so we go upward and we have to find the next node. So to find this node or state of the encoder, we need M1 and M2. So M1 and M2 are nothing but state. So here M1, M2 will be 0, 0. So 0 and 0, 0. The state changes from A to A. So that is why we represent it with A. And this is the output 0, 0. And this is the 0 represents the incoming bit. Now we will try to find the state of this next state of the encoder. So incoming bit is 0 and we need to find M1 and M2. Incoming bit is 0, so M1 will be 0 and M2 will also be 0 this side. So M1, M2 will be 0, 0. M1, M2 0, 0. Incoming bit is 0, so the state changes from A to A and the output will be 0, 0. And now we will try to find the node here. The incoming bit is 1. The incoming bit is 1 and M1, M2 we have to find. We have to look left hand side. So this is the incoming bit and this will be M1 and M2 will be already 0. So 0, 0. So 1, 0, 0. 1, 0, 0. State changes from A to C. So that is why we represent with C and the output is 1, 1. Now we try to find the state of this encoder at this node. Incoming bit is 1, and we need to find M1 and M2. So incoming bit is 1, look left side, so this will be 1, this will be M1 will be 1, and M2 will be 0, M2 will be 0, M1 M2 1 0, 1 1 0, we have to see 1 1 0 1 1 0. So state changes from C to D. We are in the state C and it changes to state to D. Similarly, we want to find the state of this encoder at this point. So initially the encoder is at state C, the incoming bit is 1, and the previous two bits M1 M2, M1 will be 1 and M2 will be 0. So M1 M2 1 0, and the incoming bit is 1 1 1 0. So where is 1 1 0? 1 1 0. Again the state changes from C to D. Here also C to D, and the output will be 0 1. In this way we find the next state and the output of the branches. The outputs will be represented on the branches of the tree diagram. To have better understanding, we will try to find, we will consider two more cases. Suppose we want to find the state of the encoder at this node. So here incoming bit is 1, and we have to find M1 and M2. This is the state of the encoder. So here incoming bit is 1, so we have to look left side. So this will be M1 and this will be M2. So this M1 will be 0 and M2 will be 1. So from the state table we observe 1 0 1. 1 0 1 will be the state changes from B to C. The state changes from B to C. So this will be C and the output will be 0 0. Output will be 0 0. Similarly, suppose we want to find the state of the encoder at this node. The incoming bit is 1, and we have to look for values of M1 and M2. So for that we have to look into the left hand side. So this will be M1, and two previous branches we have to consider. So this will be M1, M2 will be already 0 in this side. So M1 will be 1 0. So this will be 1 0. So the incoming bit is 1. The incoming bit is 1 1 0. So 1 1 0 will be 1 1 0. The state changes from C to D. Already in the state C, it will change from C to D, and the output is 0 1. This way we fill the remaining nodes as well as the output of the encoder for possible incoming message bits. By applying the procedure I have explained, we can obtain the complete code tree diagram like this. So please practice to obtain the various nodes and the output of the convolutional encoder. And now we want to find the output of the, from this tree diagram we want to find the output of the encoder for the given input 1 1 1 0 1. So this input stream we should represent here. The incoming bit 1 1 1 0 1. This is 1 1 1 and 0 1. So we have to draw the path like this. This is incoming bit 1, next incoming bit 1, next incoming bit 1, 0 and 1. So the output of the encoder will be, see here it is represented. So for the first bit this is 1 1, for the second bit it is 0 1. For the third bit it is 1 0, and the fourth bit 0 1, and the last bit it will be 0 0. This way we can find the output of the convolutional encoder for any given input to sequence. If you want PDF files of my video lectures, please visit www.engineerstutor.com. For PDF link, see description of the video. You can also write to me at rkgopal2020@gmail.com for any doubts and queries.